So the topic is exponential growth and decay. First, let's have some background information. In the natural world and the human world, we experience growth and decay, which often occurs at an exponential rate. For example, population growth. In humans, animals, bacteria, etc., populations often grow exponentially if there is no natural limiting factors such as predation or a lack of nutrients. Also, in the human world exclusively, money. If you invest money into a bank that gives you interest, the money will grow exponentially as every time interest is compounded, there will be more money, means more interest, etc. Finally, radioactive decay. Radioactive decay happens when a radioactive material such as uranium decays by releasing radiation or particles and becoming a smaller atom. Radioactive decay is proportional to the amount of substance left, so it is a form of exponential decay as it decays quickly at first and then slowly later. We solve exponential growth and decay problems with a formula called PERT. PERT is represented by the formula P times e to the power of r times t. Each of these variables represents each of the following. P is the principal or the initial amount. It's the amount you start with. E is Euler's constant, which is roughly equal to 2.718. R is the rate of change in decimal form. For example, if an interest rate of a bank is 3%, the decimal form of that would be 0.03, and that would be the rate of change. Time is obviously time, and it's represented in the units of the rate of change. So for example, if the interest of a bank was 3% per year, the time would be most likely represented in years. Now let's move on to some practice problems. Problem 1. Cesium-137 has a half-life of 30.17 years. Given a sample of 60.34 grams, find a general formula for the amount of sample left at time t. First, we need to use the formula PERT that, if you recall, is P times e to the r times t. And this is equal to f of t, where f is the function that gives the amount of sample left at time t. Now we know the initial amount, which is 60.34 grams, so we can plug that directly into P, which is the principal. Also, we know that the half-life is 30.17 years. This is equal to the amount of time needed to have the amount of sample left. So, after 30.7 years, the amount of sample left compared to the original amount will be halved. So we can write f of time of the half-life, or 30.17, is equal to 1/2 of 60.34, which is the initial amount. Also, if we rearrange this formula into the form of PERT, we can replace time. We can also replace time with 30.17 years. And remember, we also substituted P for 60.34 grams. So 60.34 times E to the 30.17 times R equals f of t, or f of 30.17, which we already know is, it's equal to half of 60.34 and then we can just divide both sides by 60.34, and then we can take the natural log of both sides and solve for r, or the rate, to get the rate equals the negative natural log of 2 over 30.17. We can plug this into the original formula along with the initial amount or principal to get the general equation of the amount of sample left at time t is equal to 60.34 times e to the negative natural log of 2 over 30.17t 1.17 all times t. So Problem 2. You have found a bank that offers 3% interest per year compounded continuously. You decide to open an account with $6,000. How much money will you have after 7 years? Round to the nearest cent. This is actually an easy problem because we already are given nearly all the information. So f of 7 years is equal to p, the principal which we are given, $6,000 times e, and we're also given both the rate and the time, which means we can just do times 0.03 times the time, 7 years. So then we can just solve for our f of 7 by just plugging this into a calculator and getting our final answer of f of 7 equals, remember we have to round to the nearest cent, so it's actually roughly equal to $7,402.07. Problem 3. Continuing from problem 2, how long will it take for you to double your money? Round to the nearest tenth of a year. Now, if you remember from problem 2, we were given that the premium, or the principal, or the initial amount was $6,000, and the initial rate, the rate of interest was 3% or 0.03. So this is R, and this is P. And right now, in this problem, we don't know the time. We want to find out how long it will take. But we do know the initial amount. We want to double the money or double our principal. So we know that the initial amount, or f of t, will be equal to twice of the principal, or $12,000. And we can just write the equation on the right hand side of the and write the principal, $6,000, times e to the rate, 0.03, times the time, which we are trying to solve for. Now we can divide both sides by 6,000 and get 2 is equal to e to the 0.03t. Taking the natural log of both sides gives us natural log of 2 equals 0.3t. If we divide both sides by 0.03, we get time t is roughly equal to, or is actually, it's equal to, it's exactly equal to natural log of 2 over 0.03. And this, we need to solve to the nearest tenth of a year. This is roughly equal to 23.1 years. So in this lesson, we have covered exponential growth and decay, when they happen, and how to solve for them. And finally, we have done 3 practice problems, one of exponential decay about radioactive materials, one about, and then 2 about the growth of money over time given a fixed interest rate. Thanks for listening, and I hope that was helpful.